everyone, I'm Rob Stone, Meta's Vice President, Corporate Development and Communications. It's great to be back at the IAF today. Please note that this presentation includes forward-looking statements, which are subject to risks and uncertainties that may cause actual results to differ materially from our views as of today. Please refer to our SEC filings for more details. So, who is Meta? Founded in 2011, we were 10 years old when we became the first metamaterial company listed on the NASDAQ. We have 9 locations across Canada, the US, the UK, and Europe. Our multinational team has decades of subject matter experience. We have more than 7.5 million square meters of roll-to-roll production capacity, and we are approaching 500 patents to secure our future business. We design and manufacture nanostructured materials and devices to deliver breakthrough performance at competitive cost across many industries. Now, you may be wondering why there's a butterfly up on the top of the slide. The blue morpho butterfly is a source of inspiration for our research. The blue color on its wings, which is so intense that it can be seen by pilots from the air, is not pigment, but created by nanostructures that interact with sunlight. So what are metamaterials? These are not new molecules, but tiny structures and patterns formed from common materials, typically at the nanoscale, which change the way these functional materials interact with light, radio waves, and other forms of energy. For example, we can make a transparent window for microwave oven doors that shields against harmful radiation while offering perfect visibility of the cooking food inside, or a transparent film to guide 5G network signals, improving coverage without adding new hardware or using any power. Metamaterials have been produced at the laboratory scale for several decades, and you can see some examples pictured here. A major challenge for the industry has been to move this technology out of the laboratory and manufacture metamaterials at commercial scale. In the early years of our company, we explored a fabless outsourcing model, but the cost was too high, so we had to develop our own production tools. Meta enjoys several competitive advantages: speed, scale, cost, and ease of integration. First, we use AI-enabled software to design a library of patterns for different applications, producing custom solutions much faster than traditional chemical synthesis. Second, we are scaling proprietary roll-to-roll manufacturing techniques, producing large area nanopatterns with high accuracy and repeatability. Finally, our functional films are cost-effective and easy to integrate. As we move to wider substrates and increase the speed of the roll-to-roll lines, our capacity will increase and cost per square meter should decline, opening more and more addressable applications. Meta is a platform technology company addressing a wide range of markets. We are developing many applications for segments including augmented reality, automotive, banknotes, batteries, communications, consumer electronics, and healthcare. We have been rapidly expanding our range of technologies and applications. Here you can see our platform technologies and related trademarks. In 2020, we had only holography, lithography, and wireless sensing. We've acquired 5 other platform technologies since then. Our competitive position is secured by a fast-growing IP portfolio, and as of our Q3 report, Meta had 472 active patent documents in 112 patent families, of which 63 include at least 1 granted patent. Now, let's look at our markets and applications in more detail. Here, you can see the estimated size of Meta's addressable markets in 2022 and projected for 2026, based on multiple market research sources and Meta internal estimates. Battery materials, our largest market, is projected to reach nearly $32 billion in 2026. Medical devices, more than $18 billion. Transparent conductive materials, which we brand Nanoweb, $5 billion. And electro-optics and photonic materials sum to almost $6 billion. Altogether, our total addressable market is projected to grow at a 17% compound annual growth rate to $61 billion by 2026. Electric vehicles are the largest market opportunity that we address today, with automotive EV units projected to grow at a 22% CAGR globally from 2021 to 2030, according to ID TechX. To meet market demands, battery makers need improved material performance, stability, and in particular, safety. Meta is developing 2 new materials and proprietary manufacturing techniques to improve safety and efficiency, as well as helping to reduce battery costs. It is important to note that these components are compatible with every lithium-ion battery, regardless of format or chemistry. First, our patented nPOR nanoceramic battery separators are uniquely heat stable for increased safety. Second, Encore polymer composite thin copper current collectors reduce the weight of solid copper current collectors by 85%, extending vehicle range while also enhancing safety. Let's dig a little deeper into what causes battery fires, a phenomenon known in the industry as thermal runaway, which occurs in 3 stages. The most common cause is when a defect between the electrodes creates an internal short. This might be a particle of metal from the manufacturing process or a dendrite that penetrates the separator. Overcharging and external abuse can also lead to thermal and mechanical stresses that may cause a runaway. In stage 1, the local current and temperature spike. In stage 2, accumulation of heat and gas cause the typical industry separator to shrink and fail. The electrolyte starts to decompose. In stage 3, the defect rapidly enlarges, generating even more high current and heat, and an intense fire ensues. Now, let's look at how serious this fire becomes. It can require more than 10,000 liters of water to suppress an EV fire. EV battery fires release megawatt levels of heat for hours. Even when suppressed, there is risk of reignition for as long as 24 hours, and dangerous gases are released by battery fires. Because the problem is so serious, EV OEMs invest a lot of cost, weight, and extra materials into battery packs and battery management systems, which are designed to contain fires or prevent propagation from one cell to another inside the pack. Battery problems are common across all sizes and types of batteries. Just this week, Ford halted production of the popular F-150 Lightning over a possible battery issue. Last week, 4 people were hospitalized after an external battery caught fire in the seat back pocket on a United Airlines flight. Now, what if you could design in more safety at the cell level? Meta has 2 components to make batteries safer. Encore, our novel polymer metal composite current collector, is designed to act like a fuse, shutting down local current in the event of a spike. nPOR, our proprietary nanoceramic separator, remains stable at high temperatures, preventing a local internal short from spreading. In combination, we believe these 2 components can make batteries much safer at the cell level and save extra cost, weight, and materials in the pack. Now, let's look closer at Encore. A thin plastic material is embedded with metal from both sides using our proprietary plasma fusion vacuum deposition technology. This creates metal layers on the top and bottom and metal bridges that conduct current through the material from one side to the other. If the local current gets too high because of a short, the plastic material melts, destroying the bridges and acting like a fuse to shut down the current at that location. Now, let's see how Encore outperforms the alternatives. Typical current collectors made of solid copper foil are heavy, accounting for more than 10% of the weight of the battery cell, and range from 8 to 12 microns thick. Metal-coated plastic substrates reduce the weight of copper, but do not provide through conductivity and pose difficulties with tab welding and high production cost. Encore is much lighter and reduces thickness to just 6.5 microns, which allows for more volume of active materials, increasing capacity and vehicle range. Encore offers high through conductivity, critical for battery performance, and a fuse-like safety feature to inhibit thermal runaway. It has better elongation to break strength compared to copper foil, which is important for high-speed roll-to-roll battery production equipment, and Encore can be assembled with standard tab welding. Finally, it's important to highlight that Meta's unique plasma fusion technology provides low manufacturing cost. Plasma fusion can deposit any solid material onto any substrate faster and more efficiently than alternatives. It operates in a vacuum with argon gas. Highly concentrated, very short pulses of plasma cause molten source material to be ablated from a rotating target. This material travels towards the substrate at such high speed that it is fused into the substrate, but at temperatures cool enough for plastic substrate materials. Rapidly repeating the pulses provides a fast, controlled deposition. We believe there is no other vacuum deposition approach that can cost-effectively make copper current collectors. We are developing roll-to-roll capabilities to scale up Encore production. Pictured here is our second-generation mini roll-to-roll system, producing 12 centimeter wide by 20 meter long rolls. This is an upgrade since we reported our Q3 results in November. We are focusing on improving material handling, deposition rate, which is closely related to thermal management, and process control. In November, we signed an MOU with DuPont Teijin Films and Mitsubishi Electric for a multi-year, multi-stage project to industrialize this process. At the end of January, the partners met for 2 days at our Oxford, UK facility, and we hold virtual meetings every 2 weeks to advance the project. We will develop a pilot scale system, followed by industrial scale equipment, and then apply plasma fusion to solid state battery production. Now, let's look closer at nPOR. The battery separator acts as an insulating membrane between the 2 electrodes. It must allow the ions to pass back and forth during charging and discharging, but keep the 2 electrodes from contacting each other. The diagrams here illustrate what happens when there is an internal short. A standard polymer separator shrinks, fails, and causes thermal runaway. nPOR remains intact and prevents a battery fire. Next, I will show you how that looks in a nail penetration test comparing 2 identical cells using all the same materials except for the separator. The graphs on the left show voltage, cell temperature, and ambient temperature during the test. The x-axis is seconds over a 2-minute period during the nail penetration test. The blue line on the top shows its cell voltage, which drops to 0. The green line is the cell temperature, which shoots up to about 700 degrees. Red is the ambient temperature, which reaches 280 degrees. In the picture, you can see the fire, which rapidly destroys the cell and would easily spread to other cells inside a battery pack. So, what happens when you puncture an nPOR cell with a nail? First, note that the graphs for this test run for almost 7 minutes. The blue voltage line drops, but then partially recovers. When the nail is removed, the voltage rebounds to about 4 volts. The cell temperature never exceeds 55 degrees, and the ambient temperature remains stable. You can see the hole through the cell, but it continues to operate. There is no risk of propagation to adjacent cells. In the charts pictured here, you can see that nPOR is much more mechanically stable at elevated temperatures compared to other separators. That's the graph on the top left. It has 5 times higher thermal conductivity, pictured on the top right, and life cycle testing on the bottom left shows a stable and long life. We are ready to scale up nPOR with high-speed, large-format equipment via outsourcing relationships. Next, let's look at Nanoweb. Nanoweb is a transparent conductive film with a range of applications: 5G reflectors, EMI shielding, de-icing defogging, and transparent antennas. It is produced with our proprietary rolling mass lithography technology. The patterned metal mesh is too small to be visible to the unaided eye. Our 300 millimeter roll-to-roll pilot production line is located at our Pleasanton, California facility. Growing our capacity is key to launching several applications for Nanoweb, and the scale-up is proceeding well. We are making 5G reflector film that exceeds customer specifications. We are also making EMI shielding film for microwave ovens and film for transparent heaters. We can address the size requirements for microwaves and heaters with 30 centimeter wide film. For 5G reflectors, we need 60 centimeters width, which we will produce either on a new internal line in Thurso, Quebec, or via outsourcing, or we'll likely do both. Now, let me share some detail on our Nanoweb applications. We believe Nanoweb EMI shielding for microwave oven doors is likely to go into production this year. We can provide the user clear visibility of the food during cooking while protecting against harmful radiation. This is a large opportunity for Meta. Worldwide, more than 70 million units are sold per year. This application was selected as a CES 2023 Innovation Award honoree, and we attracted a lot of attention, as I will show you next. CES 2023 was a big success for Meta. We exhibited in 3 locations, our booth in the North Hall, in the ATMA EV concept car in the West Hall, and in the Innovation Showcase at the Venetian. We enjoyed a very strong social media presence during CES, and on day 2 of the show, we were recognized by Buzz Radar as the #1 most mentioned brand, outpacing global corporations Lenovo, BMW, Sony, and LG. Today's sophisticated ADAS, Advanced Driver Assistance Systems, help to make cars safer and easier to drive using a range of cameras, radar, and LiDAR sensors. However, this advanced technology becomes useless if the sensors are obscured by fog or ice in bad weather. Nanoweb transparent heaters are very power efficient. Importantly, the metal mesh pattern is designed to be compatible with each sensor type. For radar, we produce a vertically polarized parallel line structure. For cameras, a randomized non-diffractive pattern eliminates glare that would interfere with the operation of the sensor. This is another application that's poised to go into production. As we scale Nanoweb to 60 centimeters and then 1 meter plus, we will open even more application opportunities on vehicles. We can add multiple functions to a smart windshield or sunroof. Compact, power-efficient de-icing and defogging saves battery power and frees up space within the cabin and dashboard design. An electrochromic sunroof can quickly adjust transparency, and embedded invisible Nanoweb antennas offer high-speed connectivity. This picture shows how Nanoweb can improve signal propagation and eliminate dead spots in 5G networks in cities by applying a transparent 5G reflector film to the windows and the interiors of buildings. High-speed 5G signals are easily absorbed and blocked by objects in the environment. We can solve this problem faster and more sustainably than adding more base stations and repeaters to the network, all without requiring added hardware or using any power. AR Fusion is Meta's platform technology for smart augmented reality eyewear. AR Fusion combines precision cast lens fabrication tools with functional metamaterials and volume holograms to provide AR wearable developers with a platform for seamlessly integrating smart technologies into thin, lightweight prescription glasses. On the left, you can see the AR Fusion automated lens casting line located in its own dedicated room in our new Highfield headquarters facility. On the right, you can see a demonstration of a holographic free space combiner display embedded within an AR Fusion cast lens. Note how you can clearly see the text on the poster through the lens along with the superimposed AR data. Our HOE delivers high brightness with low power, which is very important for battery life. Now, let's look at one of Meta's promising healthcare applications. GlucoWise is our non-invasive glucose monitoring system, which uses dual RF and optical signals transmitted through the tissue to measure glucose without penetrating the skin. The system is covered by 16 active patent documents, of which 5 are issued. Pictured here is Dr. Helena Cano Garcia, a co-inventor with our newest preclinical prototype. That is not a mock-up, it is a working system. Of course, we expect to make the final design sleeker and smaller. We plan to have a desktop version ready for market in 2.5 to 3 years. Finally, let's look at our nano-optic security business. We continue to make progress in our development work on a new anti-counterfeiting security feature for a confidential central bank. Since September 2021, we've been working under a framework agreement for up to $41.5 million over up to 5 years. So far, we have received $13.5 million in total orders, and the customer may choose to expand the scope of work with new POs at any time. If we are designed into a new banknote with this flagship customer, we expect that would lead to more denominations and follow-on business with other central banks. We are also preparing for the commercial launch of our unique plasmonic nano-optic technology, Color Optic. We have already delivered 10,000 meters of material for customer trials with good test results for adhesion and durability. Pictured here is a roll of Color Optic from the trial production. At Meta, ESG is in our DNA. We use metamaterials to do more with less, to enable safer and more efficient electric vehicles, to manage 5G signals passively without using power, and to manufacture more efficiently using our AR fusion and plasma fusion technologies. We've won multiple awards for sustainability, and we're proud to say that our principal production facility in Thurso, Quebec, is powered by hydroelectricity. Meta continues to execute on multiple applications and large market opportunities as we pioneer metamaterials production at scale. Nanoweb EMI shielding for microwaves is poised to enter production this year, and Nanoweb transparent heaters also have strong OEM interest. Both of these applications are compatible with the size and cost per square meter that we can achieve on our first line in Pleasanton, California. Via outsourcing, we may be able to effectively triple our capacity and reduce the risk of producing in just one location, which should aid OEM adoption. We are in discussions with multiple OEMs about our safer and more sustainable battery components, and we will be presenting and exhibiting at upcoming battery conferences and trade shows. Meta is a category-defining company. We are energized to continue to build value as we move ahead as the first metamaterials company listed on the NASDAQ. I want to thank you very much for your time and attention today. And if you have questions or would like to schedule a meeting, please contact us at ir@metamaterial.com.
Rob, thank you very much.
Okay, now you should see me.
Yes. There are already some questions in the chat. So Brad asks, can you give us an update on the possible government funding?
So as I'm sure the listeners are aware, the transportation transition from internal combustion engines to electric vehicles is a high priority for governments all around the world. And we're in discussions with governments in Canada, in the UK, in the US, and in Europe around various supports for our activities. Don't have any more details to share now, but there's lots of money out there to support advancements along the supply chain, and we hope to get in the way of some.
Okay. And Peter asks, have you reached your target Nanoweb production capacity for 2023, and are you still actively increasing it to prepare for future battery material demands?
So excellent questions. First of all, on Nanoweb capacity, and that's a really important topic for investors to monitor. There are two parameters that are important, or maybe three. One is the width of the web, which defines the rectangular dimensions of the various applications we can produce. So right now in Pleasanton, we have a 30 centimeter wide web. That's big enough for microwave oven doors and for the heated windows on the ADAS sensors that I mentioned. It's not yet big enough for the 5G reflector application. We can make samples, but when they start to broadly deploy, they want to have at least a 60 centimeter wide web. So the second parameter is the throughput of the line. So how fast does the web move? And that's something that is a topic of continuous improvement. One of the things that we expect to eventually do is use plasma fusion for the metallization step of Nanoweb. Right now, we're using a more standard sputtering technique in California. With plasma fusion, we think we could double or even quadruple the pace of metallization, which would give us more capacity with the same tool set otherwise. And then finally, I wanted to mention again, we are working on qualifying an outsourcing relationship. This partner in Asia already has 60 centimeter wide capacity. So if we're able to satisfy ourselves as to the ability of that partner to manufacture our Nanoweb designs, we would effectively triple our available capacity for Nanoweb, get to 60 centimeters faster. We still intend to build a 60 centimeter line and place it in Thurso, but that's going to take a year or so. So we could get there sooner via outsourcing. And in addition, having more than one production location via this partnership makes it more attractive for OEMs to adopt Nanoweb applications. Now, coming back to battery materials, Nanoweb is not involved in batteries. We're doing two things, the nPOR separators and the Encore current collectors. nPOR we can manufacture using outsourced partners. It's made by slot die coating. The secret sauce is in the mixture, which we produce internally. Encore for the current collectors, on the other hand, is in the process of being scaled up. Right now, we just have a little lab scale machine in Oxford, UK. And the next step is to scale that up to an industrial scale machine over the next year or two. Hope that helps on capacity.
Yes, thank you very much. David asks, can you elaborate on any business ventures surrounding nPOR?
So we have gotten very good feedback from various meetings as well as the exhibition at CES around nPOR. Battery safety is a very, very important topic. And our proposition is you can have all the same performance of the separators that you're using, plus greatly improved safety. And we're in discussions with multiple OEMs concerning various forms of collaboration, joint development agreements, licensing, etc. We don't have any specifics to disclose at this time, but there's lots of interest and it's going well.
Maybe in the same direction from Brad, can you speak about the LG Chem's use of nPOR, and is this a licensing agreement? We acquired the assets and IP of a company in Massachusetts called Optodot. And Optodot had a relationship with LG for many years. Back in the day, it was LG Chem, not LG Energy Solution as the battery company is known today. And Optodot licensed a first generation of its technology to LG. So there's a long-standing relationship there. We can't say more about what may be going on between our companies today, but that's the history. Rob, thank you very much. The time is up.
Thanks. It was great to be back at the IAF.